All right, eighth graders, so it has come to this. Our last day of school is not really conducive for us to be trying to finish up a test because first hour is supposed to be yearbook signing, and by third hour, they're doing the wacky Olympics for the eighth graders. It's just basically a fun day for the eighth graders. So that means we have to take the test Monday and Tuesday, which would mean today would be our review day. So it has come to this. So I'm going to review the answers to the worksheet. I know this is not ideal because ideally you'd be able to answer questions, we can interact. I will say, based on previous notes, I did mark that somebody asked about question 36 in a previous year, so I'm going to go ahead and demonstrate that one, how we got up to this answer. We can use quadratic formula for this, but because it's not solved for 0, we've got to solve it for 0. So I'll just take off 4 from there. I'll also take off 10k from each side. And now I'm going to have equals 0 on the right. Cool. As for the rest of it here, I mean, it's still 9k squared. This is now minus 8k. This is now minus 15. There's no GCF that I have to even worry about on this, which is fine. Of course, we know that our quadratic formula is going to be the opposite of b, which in this case is going to be 8. And then we'll have a plus or minus the square root of b squared. I know that negative 8 squared is 64. Minus 4 times, let's see, a is 9. C is negative 15. Okie dokie. And then underneath, I've got 2 times 9. Or wait a minute. I know what 2 times 9 is. It's simply 18. I'll write it like that. Cool. So minus 4 times 9 times 15. Okay, it's 2 negatives here that I'm multiplying together, so this is all going to turn out to be plus, right? Cool. I know 4 times 15 is 60, and 6 times 9 is 54, so 60 times 9 is 540. Fine. I still have that 60, and it's positive, but I still have that 64 up here. Okay, fine. And this is looking all well and good. Of course, 64 plus 540. Yeah, we can add those together pretty easily, and as we see, I get what, 606? No, what am I writing 606 for? Sorry, 604. I can do math. All right, now 604 though is divisible by 4, and when you've got a square root like that, when you got a radicand that's divisible by 4, you know you can break it apart. So now I'll call it 8 plus or minus the square root of 4 times, and that's 151. Okay, so yeah, this is kind of a must do because, as we can see with the square root of 4, we now have a 2 in here. And remember, when you have these binomials like this underneath a denominator or underneath a numerator that's, whether it's, plus or minus, doesn't matter. The fact that it's binomial is the important part. I can call it 8 over 18 plus or minus 2 root 151 over 18. This is now going to reduce to 4 ninths plus or minus the 2 over 18 reduces to a ninth. I still have that square root of 151. I think that's what I had. Yeah, that's what we had over here on 36 is our answer. Good. Okay, let us move on to this. Now, these answers are also going to be uploaded on a second document. I just want to, some of the problems are worked out there, and some are not. And so, like this one right here, I don't have it worked out on the document uploaded to Service Your Key, but also I'll work it out over here. And 2x minus 1, remember when you're doing your division like this, you're going to need to, you're always dividing with respect to the lead coefficient. So in this case, I would look at this and say, yes, definitely I multiply x times 2x to get to 2x squared. And of course, x times the minus 1 is going to be minus x, like so. I'll subtract. This goes poof. Cool. Negative 5x minus negative x is negative 4x. And I bring down the plus 9, of course. And I can multiply, let's see, 2x times negative 2 to get to negative 4x. Awesome. And negative 2 times negative 1, of course, is positive 2. I subtract. I'm left with a 7. So on these, when it's asking for quotient remainder, what we're talking about here is you'll have a place in the test where it says, okay, identify what's q of x. Q of x in this case, yeah, it's the quotient, x minus 2. Remainder, you only need to put what the numerator would be if you wrote it out as, x minus 2 plus 7 over 2x minus 1. When they're asking for the remainder, you can just say 7, call it a day. And that's that, okay? Excellent. So there's a number of these questions, as you see, and these are all, I have them all worked out on the key. I'm not going to over talk too much on this. I just want to make sure I demonstrate one of them at least, because you're asked to provide the information here. Okay, so one of the things we talked about in this chapter was on a rational function like this, we want to look to see where we are with the powers, the highest power used in the numerator and denominator. In this case, when the power is the same, we know the horizontal asymptote is going to be a thing, and it will, in this case, be 3 over 1, or simply 3. So I'll write y equals 3. I know I've got a nice horizontal asymptote here. Horizontal asymptotes a little different from the vertical ones. The horizontal asymptotes might be crossed at some point on a graph, by the way. So all right, we have that part worked out there. As for the rest of it, holes and vertical asymptotes, I am definitely going to need to start factoring this. So we factor 3x squared plus x minus 10. You should have this factoring at your disposal, factoring skill at your disposal. 3x minus 5 times the x plus 2. The denominator is x minus 3 times x minus 2. I'm not going to launch into a next long explanation of how we factor, because this should be under control for you. Obviously, I didn't just do that in my head. But you should understand how we factor. Notice there's nothing that canceled out. If any of these terms canceled out, had this been an x minus 2 on the top, then I'd have had a hole at x equals 2. That's not what I have here. So I'm going to write none for holes, because nothing canceled out. I do, however, have vertical asymptotes at x equals 2 and x equals 3. You see why? Yeah, if x is 3 or 2, I will have zeros in the denominator, and that's just not going to do. So I have asymptotes, and really scrunched together here, aren't they? Excellent. So as for the rest of this here, when we say is this discontinuous, well, pretty clearly it is. If I've got 2 breaks in it at x equals 2, let's answer the question where it's yes, at x equals 2 and x equals 3. Pretty clearly there's going to be a break there. There's no slant asymptotes. The slant asymptotes generally are going to happen when you have the numerator as 1 degree higher than the denominator. So if I had 3x cubed over x squared, I wouldn't have had a horizontal asymptote, but I would have had a slant one. And I would use polynomial division to determine, whatever the quotient is, that's the function of the straight line, that's the slant asymptote. So I'm going to say none on this one too. Cool. Now, this is the part that people always seem to, forget, the cross asymptote. This one is going to cross. The question is, how can we figure that out? The good news is that this is actually relatively easy to figure out, in as much as I will just take, let's go with, I want to know where this function here, I want to know where f of x equals 3. Fine. I'm just going to take this function, copy it down here, 3x squared plus x minus 10 over x squared minus 5x plus 6. I want to find out when that equals 3. So that's the horizontal asymptote. So this will actually be something I can solve. I can cross multiply this thing, but 3 over 1, of course, and let's change my color here. If I multiply this, I now get, what do I got? 3x squared minus 15x plus 18, and that should be equal to, 3x squared plus x minus 10 times 1, which is 3x squared plus x minus 10 times 1. Yeah, sure. So these are going to cancel. Aha. See how this is going to turn into a nice simple equation here now? Because now when I go to take x off of this side, I've got negative 16x, and I'll take off 18, This will go poof. and I now have negative 28. And when I go to divide negative 16x by negative 28, I'll get x equals, well, negatives are going to cancel. They both divide by 4. I've got 7/4. Hot dog. X equals 7/4 is where it crosses, or it's 7/4 comma 3. Yeah, so this will be, it's about 1 3/4. Yeah, it's definitely going to be a point right there. The x-intercepts, yeah, that's just evaluating these numbers up here for, when are those equal to 0? Well, negative 2 is obviously one of them, so I'll say negative 2 comma 0. And then I'll also have, what else here? 5/3 comma 0. Okay, so x-intercepts at negative 2 comma 0. 5/3, that's 1 2/3 comma 0. This graph, definitely it's going up like this. Now if we tried a few more points, and indeed the y-intercept is going to be, I almost forgot to mention this, y-intercept is going to be negative 5/3. That's easy enough to evaluate. Take a look up here. If x's are zeros, well, what are you left with? You're just left with negative 10/6, which is, yeah, negative 5/3. So I know I've got this down here. So pretty clearly I've got a graph looking something like this. And I don't need to know exactly where it hits, down there. If I test out some points off to the, let's start between 2 and 3. You find out there's some points like way down here. And then, of course, for the rest of these points, and I'm not even just being exact, I'm just kind of sketching something here, because you can test out, for instance, if you say, okay, what is it when x is 8, for instance, okay, draw an 8, draw an 8, draw an 8, 3 times 8 squared, that's, 192, plus 8, that's 200. 200 minus 10 is 190 over. And then you got 64 minus 40. 64 minus 40 is 24. 24 plus 6 is 30. So you got 190 over 6. So point being, yeah, so like when I do 8, I've got 6 and something. 1, 2, 3, 4, 5, 6. And okay, I probably should have put that arrow down just a little bit further. But again, we're just looking for something that indicates you understand that there's still some more graphing here to do over here on the side, like so. Oh, what else? Identifying the domain over this set of real numbers and then simplifying on this. And again, this is, if you take a look at the document I posted, you should see that the domain is simply all reals with the exception of anything that makes the denominator into 0. Okay? And then obviously cancel out any like terms. And again, you should see that on my document. And finally, this part here, simplifying, the square root of 4i. Remember, for this, you've got to be able to find the absolute value. So just as a review, and this is in the document as well, if we have that a plus bi like this, then it's absolute. The absolute value of that is going to be the square root of a squared plus b squared. And on this 4i, it's useful to understand that this is the square root of 0 plus 4i. The real number part is 0, of course. And in the formula, and again, you can look this up, keep it in notes, it's fine. We will have, and it's all dependent on what the imaginary coefficient is. In this case, my imaginary coefficient was a positive number, so I will take 1/2 of the absolute value of the number plus I times 1/2 of that absolute value minus a, and so forth. And then for this, we know that this equals square root of, let's see, what do we have here? 1/2 of, and my absolute value is 4, and plus some of the a is 0. That's just going to be, half of 4 is 2, so this will just be square root of 2 plus. I'll have I, and again with the 1/2 of, again the absolute value is 4, and the a is nothing, so I'm just going to have I root 2 right here. Root 2 plus I root 2 is our simplified square root. Okay, so I hope that helps here. With this, just make sure that you understand that, oh, and I didn't write the other one, negative root 2 minus I root 2. It occurs to me I didn't throw that in on the key either, but there. Yeah, so that's what you're looking to do on these, okay? All right, thanks so much for listening. I hope to see you on Monday. Have a great weekend, and I'll talk to you soon.